Alrighty, welcome everyone. I know it's a little sparse in here today. I'm not terribly surprised about that considering the weather. I'm a little bit concerned about that myself, so we'll definitely keep an eye on that and see how things go. But I'm recording and we're gonna talk about code for the next hour and a half or so. That's the plan anyway. I don't really have any major updates for you for today. Still trying to get caught up with grading. I'll let you know when I have more information about that. We're going to resume our conversation that we started last time about doing clean code. Last time we talked about, oh, that's not the right project. That's a different class, sorry. Last time we talked about naming. Specifically naming for not just variables, although that is where we focused a big chunk of our time, but also on methods and even classes themselves. And so I turned you loose on a couple of exercises here, and the one that I left you with at the end of class last time, I promised to circle back and talk about it a little bit more. I know that at least some of you did figure out what this class is supposed to represent. I think that's a pretty critical first step here. Calling this number thing is wrong on multiple levels. It doesn't follow the proper capitalization scheme. It doesn't give us any information about what this class is. Did you have a question? Oh, the monitors. Sorry. Yeah, that was my bad. Let me see if I can figure out why that's happening. Here we go. Thanks for the heads up. That one's on. Where are the rest? I can see that one in the back is working. I'm not sure what else I can do. There appears to be some sort of problem. I've got it on. I can see one of the TVs is on. The rest of them are not working. And I'm not gonna spend a ton of class time wanting to debug this, so I mean there's not many people in here today. You may need to pull a seat up closer to the front just for today. I'll submit a ticket to IT and see if they can't tell me why that's happening. Sorry about that. Where were we? We were talking about this class that was given to you intentionally kind of trying to obscure what it contains, the information that it contains. I know that some of you did in fact kind of figure out what this class is supposed to be doing, trying to do. Somebody want to tell me what they would call this class? Yeah, it's a fraction. Yeah, this class is supposed to represent a fraction, and I think coming up with that piece of information is pretty critical for understanding what the rest of it's going to be doing. So, renaming this fraction should be the very first step. And Eclipse, again, remember, has that refactor option. The TVs aren't working today, man, so you might want to sit closer to the screen if you can see. Okay. Eclipse has, that nice refactor option that you can use, so you don't have to go hunt down every single instance that it occurs. And then from there, I think, should hopefully be pretty straightforward to understand that this instance variable, top is a little bit non-mathematical, I suppose. Should probably be called numerator, right? And this one should probably be called denominator. Which is likely what they, not denominator, which is likely what they were called before I, went through and tried to obscure the actual names. But then the other thing that's interesting to take a look at are these method names. So this is technically a verb, do adding. It's a little clunky. I think you could simplify this as just saying, add, or add is also a verb, right? So no need to make it overcomplicated. That do just feels extraneous, not really necessary. And the same is true for some of these other ones. Product is close, right? But it's actually not a verb. That's the result. That's a noun. That's the output. So really this should not be product, but multiply would be a better one, perhaps. And so this one's probably the reciprocal and simplify, right? Use the mathematical terms when it's appropriate to do so. Down here, we'd probably call this one greatest common divisor. Its actual name instead of GCD, an abbreviation. Because not everybody's going to know or understand what that abbreviation. Maybe you didn't remember what that abbreviation was. Maybe you had to kind of think about it and figure it out. Although it does say it in the comments right here, doesn't it? That's a big hint. Anyway, I'm not going to go through the rest. Just wanted to make sure to come back and chat about that. Today, we're going to be talking about functions. We're going to be spending all of our time talking about functions. And actually, when I say functions, I also mean methods. It's probably what you'll hear them called more often, especially when you're doing Java code. You don't really call them functions in Java so much, but other languages do. There actually is a difference that I'm not sure is too important for us to get into between functions and methods. We're going to use them mostly interchangeably in this class. So let's talk about that. On Monday I talked about some rules for naming, so let's talk about some rules for methods. And again, these are mostly specifically for Java, but also do apply to other languages as well, maybe with some slight variations depending on the language. So let's talk about functions. The first rule of functions, especially if you take a look at the book that I've referred you to, that clean code book, they should be small. Now that's somewhat subjective, right? How small is small? This is our first sort of introduction to a very famous rule called the rule of 20. The rule of 20 says that no method should ever be more than 20 lines long, ever. And that 20 is not meant to be, the goal that you're shooting for. It's meant to be the upper bound. I would like most of my methods to be significantly shorter than that, hopefully in the 5-line range, right? We want methods to be small. One of my favorite quotes from the book is, think about a method in your mind that is really small, and then make it smaller than that, because that is how small we are aiming for. If we can have all of our methods be just a handful of lines, that's great. That is awesome. And this is a little bit confusing to us because I think intuitively it's a little bit confusing to us because we don't write code that way a lot of times. I don't necessarily write code that way a lot of times. So, we often start with big methods. And this is true for, I think, most people. And that's okay. We just need to remember to refactor. So we don't end up with tiny methods. We start with big methods, and then we eventually work our way down to tiny methods. And the reason that we do that is the same reason that we've been talking about actually this entire time, to make the code easier to understand. You can think of methods as really providing a label to an action, to a certain chunk of code, right? So I'm helping describe what this action is. In computer science terms, we would say that's an abstraction, right? Anytime I take a series of steps and I apply a label to that series of steps, I am now making an abstraction. And that's really what methods are at the end of the day, is applying that label to a series of steps that allows us to reuse that code over and over and over again in a particular way. But within methods, so how do we keep them small? I think another interesting thing to consider is that if statements and loops also should be small. So how small are we talking for if statements and loops? I mean, the ideal case would be the smallest possible, which is one line, right? Empty is kind of silly. But one line loops are the goal. Now, will they all be that small? No, but that's kind of what we're shooting for. And then even further, think about, you know, 2 levels of indentation or less. So every time I make an if statement, every time I make a loop, right, I have to indent to go into that body. Within one method, I'm saying I can do that twice. Any more than that, and that's a big cue that I should be thinking about making another method here, or whatever needs to happen at that lower level. And ideally, we want to keep our methods as flat as possible, not have as much indentation, any more indentation than is absolutely necessary. So we want to keep our nesting reasonable. We want to keep our methods short. All of this is back to something I mentioned on Monday. Methods and functions should do one thing, and do it well. So if you can apply a name to what your method is doing, that's all it should do. Don't make it do anything besides that. That's misleading. That's misleading in a different way, right? Don't make it do 10 different things and then call it one of those 10 things, because then somebody's going to be really surprised when they expect it to do that one thing and it does those 10 other things as well. Those are called side effects, and they're generally kind of frowned upon. So choosing the names of methods is very, 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 very important. And when we're refactoring, I'm constantly looking at all of the code and trying to think, can I apply a name to this action? Can I apply a name to this level of indentation, right? To this if statement, to this loop? If so, then I'm going to extract it out and make a method, which tells you that we're going to have a lot more methods, probably, than you're used to writing. That's a good thing. Computer scientists should have lots and lots and lots of methods. I want to get away from what you see in, especially in 131, when you start out, everything is just in one big method. That's a huge no-no, right? The more methods we have, the better. So let's talk about some kind of subspaces within methods that are worth discussing. Specifically, I'm talking about parameters, right? It's a big part of methods, big part of functions. They take parameters, both input, and then they also have return values as well. Both interesting to think about. Since we're trying to keep our methods small, we want to have as few parameters as possible as well. And so to think of, you know, some general rules, right? 0 is great. If I have a method with 0 parameters, awesome. It'll work the same way every time. Sometimes that's okay. Sometimes that's all I need. I don't need to tweak the behavior of it. 1 parameter, also good, right? 1 parameter is not a problem. Parameters are useful. Parameters help us write methods that are more general, so we don't have to have as many of them, and helps us keep them short. But then, you know, how many parameters before is too many? I think you could agree, right? Having 20 parameters is probably a bit much. I don't think you would be happy if you had to call a method and list out 20 things in the parens, right? But how much is too much? Where is that line? I think it's probably a bit sooner than you might expect. You know, now you're pushing it with 2. It's okay. And then 3 is the absolute max, but avoid, right? This is surprising to a lot of students. You're saying 3 parameters is the most that you're willing to tolerate for your functions? Yeah, absolutely. If you're writing lots and lots and lots and lots of small methods, you should not need a giant list of parameters to make those things happen. This is something that on the project is, I think, one of the trickier parts of maintaining clean code. Sometimes students do have trouble writing larger methods, and I will call you on that on the project, but also the number of parameters. If you find yourself with a bunch of parameters, here's a good tip. Then you need to use objects. And that's actually our last kind of clean code conversation that we're going to have next week on Monday, right? If you're finding yourself in a place with a method that has lots and lots of parameters, well, some of those parameters might be instance variables in an object that you can create. So using good object-oriented design, keeping everything encapsulated in to objects. It's going to help reduce the number of parameters you need and make your code cleaner. Make it easier to keep your methods short and tidy and keep it clean. Let me see. Let me see what else I need to discuss before we take a look at some code. Nope, I think we're good. Let's take a look at some code examples. I think this is obviously more useful than me just kind of sitting up here and talking to you about these things, although having these rules of thumb is good. I think it's very handy to have, you know, like the rule of 20. Methods should be less than 20 lines long. Stuff like that. Fewer than 3 parameters. Those are good general rules to be aware of, but let's see what we can do in practice. I'm going to pick up where we left off with the dice example. This is a classic 131 intro style example where there's only one method. It's all in the main method, and we actually don't expect them to use methods at this point. They don't know what they are yet. We haven't taught them what methods are, so this is expected. But we know what methods are. If I made you do this assignment, I would expect you to put some methods into it. So how do we do that? Well, let's start looking at the code and see if we can't identify some places where we can put some methods in. Specifically, I like to start by looking for the farthest indentation levels and then kind of take a peek at this and say, hey, can I give this a name? Can I describe this action with a name? So if I look at this, I'm rolling a die, I'm putting it into the table, I'm keeping track of the sum, and I'm printing it out. I mean, it looks like I'm just kind of rolling the dice, right? Or maybe I need to take one step out and look at the loop as a whole. That's also not a bad idea. If I can't apply a name to just the inner part of the loop, can I apply a name to the entire loop itself? This is one throw. This loop represents a throw. So remember from last class, I'm throwing a group of dice over and over and over again. The constants are defined up here at the top in terms of how many dice we're throwing. So I think this is actually probably a pretty good candidate. I think you can make an argument for either of these being candidates for methods. This is a roll, and this is a throw, and throws are made up of multiple rolls, right? That's abstraction. That's applying a name to a series of instructions. Let's give it a try. The way that we can try to do this is by highlighting a section that we're interested in refactoring out into a method, and then we're going to right-click on it, go down to our refactor method, which is right here, and now the option I'm going to be working with pretty much entirely today is this one that's called extract method. So Eclipse will take that chunk of code out, extract it into a method, and then it's going to let me decide, okay, what should the parameters be? And you might see that already we have a little bit of trouble here, right? Because I've got more than 3 parameters. Well, let's deal with that problem later. Let's see if we can't just extract some good methods out, and then we can come back later and see if we can't reduce the number of parameters. So for now, I'm going to extract, oops, actually skipped a step there, sorry. I'm going to Control Z and do that one more time. All right, I need to name it. I need to name it up here. So this is roll. This is rolling a die, right? I'm rolling one die and recording the result of that roll, right? And if I want to be a bit more specific about these variable names, I can do that as well. I represents actually the throw number, right? The number of the throw that I'm currently on. And J actually represents the die number. Which die out of all of the die am I currently rolling? So we can include that as well. We'll extract that out into a method, and you can see that after I do that, what happens? Well, it replaces that chunk of code with a method call, which is great. That's awesome. Glad that it did that. And then the method gets declared and defined down here, and you can see it copied that big chunk of code and even rename these parameters for me properly inside of this method. It looks really good. Set up a return type for me. Although, is that strictly necessary? It is worth definitely double checking, right? to make sure you understand what's happening and making sure you understand if it's all really necessary. Because Eclipse isn't going to understand your intent. So you do have to kind of verify. I do have a little bit of a problem with the way that it's doing that. But see, it's passing it in and then passing it back out. I think I think we could eliminate this parameter entirely by just returning the value that gets rolled, correct? Do you see where I'm going with that? So it's not a perfect refactor, but let's do this, and then I can take this line out, and I can take this line, or I can take this parameter out, and that gets me down to 3 parameters, which is acceptable. And now it's just focused on the die roll, and then when we come up here, we'll do plus equals. Oh, I need to say, wait, what? Oh, it's because I took that parameter out. I'm sorry. There we go. Yeah, so I kind of added a little bit of refactoring into the refactor to make it work out properly. I like this improvement a lot, though, so far. And I want to keep going, right? I want to do this a few times, and because this is tricky. This is not easy, especially if you haven't done it before. Especially if you've tolerated large methods before, you're gonna have to train yourself not to tolerate them as much anymore. So let's practice a few more times, and then I'll turn you loose on an exercise of your own. I'm gonna keep working with this section here because I think there's a good chunk that I can refactor kind of right here. This is where it's doing the actual throw. So let's extract all of that out. And we'll call that throw dice. And I is the throw number again, just like it was before. And now we can see that this loop is becoming a lot more manageable. The main method itself is also becoming a lot shorter, which I like. And I've got these two methods down here. There are some things that I don't like about them, but we're making progress on this. Returns the sum. And then actually I could remove that. Well, yeah, that would require an extra parameter. I was going to say I could eliminate the need for the return value if I do this line in there as well, but then I would need to pass in the frequency table, so I'd have to add an extra parameter. I'm not sure that I like that trade-off. I do like taking this line, though, and moving it closer to where the code actually is performing that activity. This loop here was to check for Yahtzees. And so either it is a Yahtzee or it's not, right? I think this is a great example of extracting, potential example of extracting a method out that has a Boolean return type. True if they are Yahtzee, false if it's not a Yahtzee. Let's give that a go and see. Or I talked to you last time about how, wow, that's a lot of, well, no, it's only 4 parameters. So for Boolean methods, it's typical to start it with is or are, because it's answering a yes or no question. So are all dice equal? Or something along those lines. We don't actually need this Boolean. That's actually going to become our return value, so I will try and get rid of it. I can. Parameter name. Alright, I'll just have to delete it after then. don't know why I couldn't delete it right there. Clips would not let me. This was throw number. Oh no, and that's I though, that's the actual argument. So then what I need to do is come down here and take this out, because we are just going to return the proper Boolean value, and that'll be enough to take care of this. We can actually yeah, this is a little clunky. I can remove a line here, do some more refactoring. Cool. And already you can see how much that big giant loop that I had here has has managed to shrink just by adding in those three methods. I'm actually, it feels pretty satisfying to start with that big old block of nasty-ish looking code and start to extract all of these methods out. You know, try and see if I can keep going, because if I could somehow condense this whole thing down even further, that would be great. It's still kind of a long main method, right? Let's see. This is all computing, doing the throw, computing the sum, checking to see if they're all the same. This whole thing together, I mean, it is all part of, I don't know. I think maybe the smarter play would be to try and, yeah, I don't know. It's a little tricky. You could certainly extract this out to a method as well, called, what would this one be called? Play dice game or something like that. Play Yahtzee. 5 parameters. Wow, that is a lot of parameters. Some of them, I think, too, could be extracted from the array. That's a good way to eliminate parameters. We can actually ask the array how big it is instead of using the parameters. So that's kind of a good example of using objects when you can, right? Let me finish this one up real quick. We can take a look at how the final refactor looks. This one's still a bit long. But that's okay. Yeah, so instead of using these variables, we can just grab the rows and columns out of the array. And that'll save us those parameters. Which one is which? Yeah, that's the rows and that's the columns, so this will be the columns. Cool. And actually, I'm not sure, you know, we don't need this parameter either for similar reasons, right? For the throw, yeah. Can eliminate it from these other ones as well. By asking for it from the table. That's a good refactor right there. I like that. Okay. Once I finish this up, which I'm almost done doing. Cool. Oh yeah. Look at how short that main method has got. We're actually technically under the 20 line. Are all my methods under 20 lines now? Beautiful. All my methods are under 20 lines now. Honestly, I would want to keep going if I can, right? I don't want to stop just because I got everything below that 20 line threshold that I'm aiming for. That's kind of the bare minimum. That's kind of the, you know, the least we can do to keep our code clean and organized. We ideally would like to make these even shorter and keep things going. But I'm going to pause here and see if anybody has any questions about what I've done so far. Because if not, our next task. Oh, did you have a question? Yeah.
I had one sort of question about parameters. So
Yes.
For like a constructor for a class, would that also have a cap of 3 parameters?
That's a great question. The question was, what about constructors for a class? And that's a tricky one because recall good object-oriented design says constructors have to set all of the instance variables. So if you have more than 3 instance variables, then it's very likely you could have a constructor that with more than 3 parameters. And I think that is an exception to the rule in most cases. Although we're not quite there yet. We're going to talk about objects on Monday, but you may not be surprised to hear that we don't really want to have a bajillion instance variables either, right? There's an upper limit on how many of those we want, but it's more than 3. We can certainly have more than 3 in an object. It can be useful to do so. So that's a good question. Yeah. Any other questions before I turn to you, Luis, and have you give this a try? You're welcome to actually. You have an option. You can choose your own adventure a little bit today, and we don't even have half the class here, it looks like, because of the weather, so going to keep things kind of chill. You can continue working on this one. I think there's actually more work that can be done on this one. Or I think the other good one for extracting methods would be this one, the Gambler's Ruin problem. So those would be the ones that I would suggest that you work on for the time that we have. I've actually, gotten through everything that I was hoping to cover today. So my plan was to let you work on this for the next 15 or 20, and then maybe work on Gambler's Ruin a little bit to wrap up for today. But yeah, I'll be around if you have any questions. Give it a try. It's tricky. It's not easy, but the best way to get better is to practice. So give it a try. Let me know what you figure out. And we'll chat about the Gambler's Ruin probably at least a little bit before we wrap up classes. Okay. It's just that kind of day today. going to give you some more time, but this is driving me crazy, and it's also starting to pick up outside. So I'm going to attempt to talk over this noise for just a few minutes to go over this example with you, and then we are going to call it a day, because today is just one of those days, unfortunately. Actually, real quick, before I hop into that one, I did refactor this one a little bit more, and I'm pretty happy with it. I managed to remove some more parameters. There are some things that I'm still not happy about that I think we'll actually probably address on Monday when we get some objects into the mix, because right now there's no objects in this example at all, right? So I think once we have a conversation about objects and insert some objects into this program, we'll be able to refactor it even further still, show some more progress on how to make this look good in our next class. But for now, let's take a look and chat about at least a few methods in this Gambler's Ruin problem. It might be tempting to kind of skip this scanner stuff up at the start, but I actually think this is a good candidate for a method. Just even these two lines right here. Remember, short methods are not bad. Short methods are good. So if I can look at a chunk of 2 lines and I see that chunk repeating multiple times, then my brain says that should be a method. Let's put that into a method. So even just this simple chunk of 2 lines right at the very beginning that's asking the user to put something in, I'm going to extract that out, and I want to reuse that actually, I think, on some of the other ones as well. So what I'm really doing is, I am, let's see, read int from user, right? I'm reading an int from the user, from the keyboard. And there's a little bit more than that. You can see the refactoring. Oh, why did it do a bad job of indentation even? That's a little strange. But it copied the prompt down here as well. And that actually needs to change. That's an additional parameter that I think we need as part of this method. But yeah, let's go ahead and we can insert that one ourselves. Please enter the, and then prompt, I'll call it. Doesn't exist yet, but we can fix that. And now I have a method that can be used. This is not a well-named variable now. It's not just this. It's not going to be just the start amount, right? So that's worth a renaming. User input value. I don't know. User inputs may be fine. Yeah. And now we can actually return back up to the top and fill in the prompt, and then reuse this method for the other input values as well. Now, unfortunately, this one is a double. So that one is not, I'll need a separate method for that. And you might be thinking, well, that's a little bit unfortunate, right? But I still think it's worth doing. Oops. I still think it's worth doing, even though it's just the one. Again, our goal is not necessarily to reuse code as much as possible, though that is a goal, but it's also to improve the readability, make as many small methods as possible. I can apply a name to this, right? Read double from user is what I'm going to call that one. So I think that's definitely worthy of getting its own method as well. So, finish this one out. We've already done a pretty good job of refactoring the first part of this code. Do this one real quick. Okay, I'm just going to leave that one as is for now, although I probably should go down and refactor the variable names and stuff like I did with the other one. Aside from that, I think, of course, like we saw in the previous example, the big target's going to be, trying to fix something like trying to fix this. So for Gambler's Ruin, I'm looking at the body of the loop, right? This is playing a game. This is playing a game at the casino. So that could very easily be extracted out. In fact, we actually probably just want to check to see if we're going to win or lose and have it return whether we win or lost, and we can update the current amount perhaps outside of this method. Let me refactor and show you what I'm talking about. So yeah, it's returning the current amount. I think instead of doing that, we probably want to return a Boolean, because when you play a game, you either win or you lose. And the amount that we get is based on that information. So I would say we don't need this as a parameter. What we need is to say something like if play game current amount plus plus, else current amount x minus. I don't know if that's actually worth it, because then down here that changes this whole thing to, yeah, actually now I don't know if I like that method. I'm changing my mind. That's not uncommon, honestly, for me to do when I'm refactoring stuff. Sometimes you gotta try it and look at it and it doesn't look as great as you think. It definitely happens. I think, yeah, I may have changed my mind again. Can I go back to the refactored version? I think I may have changed my mind again. I think we'll actually just do a very, very short, simple method like this. Return greater than win chance. There we go. This one I think is good. Oh, it's called chance of winning. My bad. And switch that to a Boolean, like I said. This one I think is good. Yeah, this one I think is good. Because it's very short, but that's not a bad thing. I think even I still feel a little silly writing methods that are, this short sometimes. But try to resist that urge. Short methods are a good thing. This does accurately describe what's happening here. It plays the game by drawing a random number and then tells me whether I won or lost. That's an action, right? That's a behavior. It does that thing. It does it well. That's what methods are supposed to do. So actually, I changed my mind. I do like that one. And then up here, we can, adjust our current value accordingly. Didn't actually shrink this chunk of code down a whole lot, did it? But that's okay. The last very easily targetable, I mean, there's more work to do up here, but I'm kind of trying to jump ahead a little bit. The last very easily, I think, extractable one is down here, where we can, and this is a really nice one. I don't think this one should have any, well, no, it will need to have some parameters, yeah. But, compute expected value is a great way of extracting this last one out. And then actually that kind of tells us that, well, wait a second, we could also extract, basically all of this top part out into another method called simulate, expected value or something like that. And so now we've greatly shrunk our main method down. Ooh, that is a lot of parameters. I don't like that. 5 parameters, gross. We may address that next class when we talk about some objects, see if we can use some objects to cut down on that a little bit. But in terms of the methods, we're definitely making progress here. I think if you can figure out how to extract 1 or 2 more out of this simulate expected value method, which is still, I mean, it's almost in that 20-line range, but I still think, again, 20 is not like hit 20 and you're done. That's the upper limit, so try to keep going if you can. I think there definitely is some room to keep going on this one. I would encourage you to push yourself and see if you can't come up with some other methods to extract out of here. Again, the only way you're going to get better at stuff like this is to practice. Practice it out. Cool. I'm going to go ahead and call it a day.